right, so section 10.1 is areas of regular polygons. Do you guys remember what it means to be a regular polygon? Regular polygons have all sides congruent, all angles congruent, right? So we're going to be talking about regular polygons today. So the first one we're going to talk about is the area of an equilateral triangle. I've actually already taught you this formula. Do you guys remember we did this when we did 30, 60, 90 triangles? So the area of an equilateral triangle is the square root of 3 over 4 times the side squared, right? So whatever your side length is, which I'll write is like a little lowercase cursive s, it's going to be square root of 3 over 4 times side squared. Okay, and that comes from, I don't know if you remember this, but I'll show you again. If you have 30, 60, 90 triangles, and you know that each side is s, oops, that's an s. All right, so this whole thing's s. Then what's this red line right here? From here to here, what would I call it? Not s, but half s. And this one would also be half s. And then that allows you to find this distance. So if you remember, if you have a 30, 60, 90 triangle, we talked about n, 2n, and n root 3, right? So this is going to be our half s multiplied by root 3. So it ends up being root 3 times 1/2 s, which is root 3 over 2s. So our area of a triangle is always 1/2 base times height. So I have 1/2 s times height is root 3 over 2s. So do you guys see where the s squared comes into play? Because we got the s and the s. And then our root 3 over 4 ends up being 1/2 times root 3 over 2. So we get root 3 over 4 on the bottom. Make sense? Now you could derive that every time. Like you could find that every single time. But it's easier just to memorize it, right? It's not really that hard to memorize. So we can do that. So if it says find the area of an equilateral triangle with 12 centimeter sides. Yeah. So if I find something with 12 centimeter sides, that's going to be my s, right, is 12. So I'm going to have root 3 over 4 times 12 squared. I would find 12 squared, which we know, right? 144. And then I take that 144 and I divide by 4. So I get root 3 times 36. So I would write this area as 36 root 3. Units? Centimeters, squared, it's area, right? All right, easy enough? So what if it says something like, find the area of an equilateral triangle whose perimeter is 9 inches? Well, if the perimeter is 9 inches, what's the side length? 3, totally. So then you plug it in, so you get root 3 over 4 times 3 squared. So I get 9 over 4 times root 3. Lovely, huh? So you could find a decimal approximation if you wanted to, but usually I leave it as this exact answer. So like with square roots, with fractions, and so on. Did I do that too speedily? Did you not like that? Do you see how it's 9 over 4? Because the 3 squared is 9, right? Then we had root 3 over 4. Okay. So when we talk about polygons, we're going to use weird words. Okay, so the weird word that we're going to learn today is apothem. Some people pronounce it differently. That's how I pronounce it. I don't know what it is. So I've heard other math teachers say other things, and I'm always like, what are you saying? I don't know how else you would pronounce it. Like, what comes to mind? Apothem? I don't know. But I've heard people say it, and I'm like, that seems so wrong. It's apothem. But maybe that's just my Indiana way of saying it. Who knows? So anyway, so we have the center of a polygon. A center of the polygon is basically if we circumscribe the polygon with a circle, it's the center of that circle. Okay. The radius of a polygon, or the radius of the polygon is going to one of the corners. So this is called the radius. And here's the fancy apothem word. So it's if we drop from the center point, all the way to like the midpoint of one of the sides. That ends up being the apothem.
Wait, how do you spell it?
A-P-O-T-H-E-M.
Thank you, sorry.
It's a great mathematical spelling bee word. You know, I made a mathematical spelling bee list for Pi Day, and I never did it. We should do that someday. Wouldn't that be fun? circle drawing competition and we already had the circle drawing winner. You know, no big deal. All right, so why is this Apothem thing important? Okay, so it's important because basically we can come up with the area of these polygons using that Apothem. Okay, so look at these pictures here. So see on the first one how I have a pentagon? If I talk about this triangle right here, how many of these triangles fit inside of that pentagon? 5. Did you guys all see the 5 triangles? So basically, if I can find the area of this one triangle, could I find the area of the entire pentagon? Yeah, because I'd multiply by 5. Does that make sense? So if I'm finding the area of this one triangle, it would be 1/2 base is S times height is A. That would be that single triangle right there. And we'd say, well, we actually have 5 of them. Does that make sense? So this next one would be the same thing, but now how many do I have? I have 6, right? So I'm going to have 6 of the 1/2 S times A's. I'll leave it like that. That's fine. And then this next one is, I believe, an octagon. So it would be 8 times 1/2, and then S, and then A. Okay, so really not that hard. We know how to do that. So I think sometimes when people get these regular polygon problems, they like freak out and they're like, I don't know how to find this area. I forgot the formula. Like, it's not all about formulas, right? It's about knowing where this formula comes from. It comes from breaking it into these little triangles. Okay, so the formula has to do with 5S, 6S, and 8S. What do you think 8S is? What is that? What's another word for it? I heard someone say it way back there. It's kind of circumference, but it's not a circle, right? It's the, I did draw it like it was a circumference. I drew a circle around. It's 1S, 2S, 3S. What do we call that? Perimeter. So all of these involve the perimeter. Do they all have the same formula then? If I replace 5S with P, I get 1/2 P times A. On the next one, I get 1/2 P times A. And on this last one, I get 1/2 P times A. It's all the same formula. 1/2 perimeter times Apothem. Now notice in this equation I have 2 A's. Is that confusing for you guys? Area is capital A. Little a is Apothem. Can we handle that? I know that's super frustrating in geometry, but like you got to get used to that because we're going to have variables that we use like in calculus. Little f and big F mean totally different things. Isn't that frustrating? Yeah, we just like to mess with you guys. We run out of variables unless you want me to use Greek variables all the time. All right, so the area of a regular polygon, it says the area of a regular n-gon with side length S is half the product of the perimeter and the Apothem. So A is equal to 1/2 PA. Okay, so if I have something like this pentagon, I could do this where I find the area of just this little tiny triangle, which has 8.0 here, right? And I could say, oh, it's going to be 1/2 that base times the height, and then I have 5 of those red triangles, right? You can do it that way as well. You don't have to know this formula. Colin, you with me? So I'm going to have 1/2. I'm going to do 1/2 perimeter times Apothem. So I'm going to have 1/2. What's my perimeter? 40. Right, because there's 5 sides that are 8 length. And then my Apothem, yeah, 5.5. So I get 20 times 5.5. So I get 110 square inches. Easy enough?
Yeah.
It's really not a bad section. We like area and volume. It's bad. It's not bad. All right, so find the area of a regular hexagon with side length of 20. This one gets a little bit weird. What are we missing? Yeah, so it's like, oh, okay, I got my 1/2. I got my P, which would be 120. But my A, oh no, what is that? So what we do is we connect to the center and we create that little red triangle that I was talking about. And we need to find that A. The key to these problems is always to think about our central angle. Do you know what I mean by central angle? So I want to know what's the angle between the 2 red lines here. What do we think? 60. I agree. Why do you say 60? Yeah, there's 6 sides. Do you guys see what she's saying? So she's saying, well, if I have this, oh man, I should have drawn two hexagons here. She's like, if I connect to the center with all those, then I have six triangles, right? And I know going all the way around, I have 360 degrees. So that means that just one of these is 60. You get it? So then what are these individual ones? They're 30. So we have a triangle that was 20 all the way across, right? So it's going to be 10. Oh, man. And it has 30 degrees up there, and it will have 60 degrees down here. We have a 30, 60, 90 triangle. So we know that if we have 10 as our short length, that means that we're going to have 20 for the radius of the polygon, right? We're not using that, though. We're using the apothem. What's the apothem?
10√3.
You got it. 10√3. Don't you love how everything in math just kind of circles back around? You never lose it. You keep using it. Right, so we do get 10√3 here. So we have 60 times 10√3, so I believe we get the lovely 600 square root of 3. And our units are centimeters squared. Was that a lot? Did I lose ya? What if it wasn't a 30, 60, 90, and what if that angle was like 54? Oh, well, you know what? I'm always mean to you guys. Yeah.
How come like when they're doing examples or just doing math, it's always like either 5-sided, 6-sided, or 8-sided, never 7-sided?
I know. Why can't it be 7-side? I like 7 sides. Is everybody hating on the heptagon?
Exactly.
I don't know. I typed these up, so I don't know. I guess I think maybe it's because Microsoft Word only gives you options of these even ones to draw, and it's just such a beautiful drawing, isn't it? So
You should just put like a 7-sided one.
I should.
Will you?
Okay, just to make you happy, and I'll hole punch the test too.
My whole world.
All right, so here we go. So Michaela is designing a garden around a rectangular hexagon gazebo with side length of 6 feet. The garden will be a circle that extends 10 feet from the vertices of the hexagon. It's not really drawn a scale, but this is 10 feet here. What is the area of the garden? So we're going to draw this little triangle in here, and luckily it's one of these 30, 60, 90 ones, right? So if I have 3 and 3, we know that we have 60, 30, and we had 3 down there. So what is the apothem? 3√3. Sophia's on it. Is everybody else on it?
No.
The radius is going to be 6. So we're going to have 3√3 right there. And then this is 6. Now that radius is actually important on this one. Okay, so I need to find the area of the circle. So sometimes if I'm finding the area of different things, I'll do area of circle, area of hexagon. So I can kind of organize things in my head. I'm like, okay, I got the area of this, the area of this. You can write out the word hexagon too if you don't want to draw a little picture. Cam, you with me?
Yes.
So the area of our circle is pi r squared. You guys already knew that. I wrote it in parentheses just in case. But the area is pi r squared. So we have pi, our radius, squared. And do you guys see what this radius is right here? Now, it's not the radius of the polygon. It's the radius of the whole circle. This distance was 6. So what is this whole distance here?
16.
16. You got it. So we're going to have pi times 16 squared. So we have 256 pi. And then we want the area of a hexagon. So the area of the hexagon is 1/2 PA. So I'm going to have 1/2 my perimeter. Well, what's the perimeter of the hexagon? 36, because there's 6 sides that are all 6 units in length. And the apothem was that number we found, the 3√3. So I start reducing. I'm like, okay, half of 36 is 18. 18 times 3 is 54. So I'm going to have 54√3 as my area. So that means the area of the garden, maybe you could do A with a subscript flower, I know that area of the garden is what? So we're going to have that 256 pi minus 54 root 3. Okay. And right now it kind of looks like gibberish. Like if I was trying to figure out how much grass seed I needed, or I don't know, something, mulch, whatever, I wouldn't really know what that number is. But if you need to actually multiply it out, you could. So you could do 256 pi minus 54 root 3. And so we get like 710.717. And my units are square feet. And that might be a little bit more useful to us, right? So if I say, oh, you know, grass seed is 75 cents per square foot, right? Then you could say, okay, I'm going to have this and I'm going to multiply it by 0.75. Right, it cost me, that's really expensive. It's not 75 cents. It's like $533 for grass seed. That seems a little steep, right? All right, but you get what I'm saying. All right, so number 4. So a stop sign is a regular octagon. So the signs are available in 2 sizes, 30 inches or 36. Find the area of a 30-inch sign and find the area of a 36-inch sign. Okay, so I want this side of the room. You guys are going to find the 30-inch sign. And this side of the room, you guys are going to find the area of the 36-inch sign. So this 30, when we talk about 30, we're talking about all the way down this way. Okay, so I see confused faces. Rhett's like, what? Do we really have to do this? Rhett, what are we having to do? That you're like, I don't want to do this. Is there something that you're like, oh, that's not very nice? No, you're good. You're powering through. Ian's saying, yes, there is something that I'm like, I don't want to do this. All right, the issue is that we now have this, octagon now. It's not a 30, 60, 90 triangle, right? I don't know, what is it? So if I have this angle right here, there would be 8 of them going around, right? So I have to do my 360 divided by 8 to get that angle. And it ends up being 45. So that means that this little angle right there isn't 45, it's half of that, 22.5. Lovely. I know, you guys are all like this. Like hand over your mouth, like, oh no. Because we can't do 30, 60, 90 triangles now. This is like what Charlie was saying, well, what if it's a heptagon? Those aren't going to be nice numbers. It's not nice for an octagon either, right? Because now we have to use Sohcahtoa, our fave. Oh. I told you, everything just comes back. You just think we don't need to know it. It's like we're reviewing for the final already. All right, so we want to use Sohcahtoa, so we're going to say that we have opposite, right? Here's our angle. We have opposite and we have adjacent. So we want tangent. So we're going to say tangent of 22.5 is equal to opposite, which is x, over adjacent, which is 15. And we multiply. So we do tangent of 22.5. We find that answer and we multiply by 15. And that gets x, which is 6.213. So what's my side length then? How do I find the side from that? Multiply by 2, right? So it's going to be 12.426. How do I get my perimeter then? Multiply by 8. I'm keeping all these numbers in my calculator, so I have 99.411. You with me? I wish you could do this with your equations and just move them over. So handy. All right. Was it this class that was saying, I wish we had an extend page? Because I always hit extend page at the bottom of the page.
Why do,
all right.
Well, why isn't the AP exam on, like, not paper? Or, like, why is it?
Oh, I don't know. Wouldn't that be hard to take it on the computer? You gotta show your steps.
You
Get
can write
points for
out, like,
steps.
like for AP Chem or something, it's really hard.
All right, so Apothem. What was the Apothem? We actually had that, right? That's 15. So we take that number, I multiply by 15, I multiply by 1/2. So I get 745 something. I guess I did it for you. I told you guys to do it, and then you had blank looks. All right, does this make sense? Do you guys get it?
Yes. It's a lot of steps.
It is a lot of steps. So the next one would be very similar, except its x value would not be the same because we wouldn't have 15 now. How long would it be from here down? Yeah, it'd be 18. Does that make sense? So then we'd have 18 times tangent of 22.5. So write these numbers down. So we got an x value of 7.456, which gives us a side length of, multiplied by 2, 14.912.
Wait, how did you get 18 again?
Because we knew that the length from the top of the sign to the bottom of the sign was 36. So we divided by 2. And then our perimeter then is multiplying by 8. So we're going to have 1/2. This time it's a little bit bigger. It's 119 something. So 119.294 times our 18. All right, so I wanted to find this number because the next question is one that you'll see occasionally on tests and things, like standardized tests. Do you guys remember this from algebra? So it says, find the percent increase in metal needed to make a 36-inch sign instead of a 30-inch sign. Have you guys noticed that stop signs are different sizes? So we're saying, like, how much metal is needed in order to do this? So we would increase it. Caitlin, put that away, please. We would increase it by doing our change. So percent increase is always the amount of change divided by the original. Okay, so when I say amount of change, I mean take those two numbers that we had and subtract them. So I'm going to take that 1073 number, and I'm going to subtract out the 745 number, and I get 328 something. And if I divide by the original, like the smaller number, because I'm talking about a percent increase, I get my percent change. So it looks like this. What does this mean? Yeah, 44%. So we multiply by 100 in the end, right? So if you ever see percent change, what it is the amount of the change divided by the original amount. That will find percent increase, percent decrease, and so on. All right. One last of these, and then we're moving on to some other concepts. So it says, find the area of a regular dodecagon with a side length of 24 millimeters. So think about how to do that. You don't have to draw the entire dodecagon. That's a challenge, right? Just draw a little bit of it. I would love to see you guys try to draw a dodecagon, but
Can that be our next contest?
yeah. Oh, a contest in dodecagon drawing? I do have a lot of trophies in my drawer. And crowns. I have like little king crowns. Yeah. All right, so I want to know how many degrees is there. I take my 360, I divide by 12, I get 30 degrees. So in one tiny little sliver, right, if the whole thing was 30 degrees from here over, what's half of that? 15. So we're going to have 15 degrees here. And the side length was 24 millimeters. Well, that means that this part's 12, right? Because we're kind of breaking it into its two pieces. You see what I'm talking about? So we want the apothem, the A. So we use tangent. So we're going to say tangent of 15 degrees equals opposite over adjacent. But you got to be a little bit careful because we're going to multiply the A over, and then we have tangent of 15 multiplied by it. So we're going to do A is equal to 12 divided by tangent of 15. So I got it was 44.785. Okay, yep, you have a couple like this on your homework. You have to you don't draw the whole thing, right? It's hard to draw. So we put it all together and we say area is equal to 1/2 PA. So it's 1/2 the perimeter. What do we think for perimeter? How do I find it? 24 times 12, right? So 288 times the apothem, the 44.785. So our number is 6,449.04 millimeters squared. Do I have something after that? Oh, that is the end of the section. Okay, does this make sense?
Yeah.
All right, so it's a little tricky. You use 30, 60, 90, which you could also use Sohcahtoa for those as well.
It's crazy. It's like
And then you have Sohcahtoa. Yeah, it's like all this stuff that you've already learned,
Is
right?
it usually just tangent